Good morning, everybody. Thank you very much, Betty, for your introduction. Again, my name is Julián Jaramillo in Spanish. In English, it's Julian. And in English, my last name, they pronounce it Jaramillo. As Betty said, I'm an application engineer. Been with Eaton for almost a decade. And I attend the North Andean region, covering the Colombian Ecuadorian markets. Edge or no edge? That is the question. First, we're going to start off with some little, questions we should keep in mind to give you a diagnosis if edge computing is applicable for your business, market, etc. Some macro trends to see where the technology is leading us towards. We're going to define what edge computing is, what are the needs in the industry for edge computing, the types of edge computing, how to calculate energy in order to set up a proper edge computing in your business, and some control questions. So the questions we should ask, if we want to look into edge computing and give a diagnostic is, first of all, what is latency? How do we measure latency? What is edge computing? What is a GPU? For all of you, and what are its applications? Graphical processing unit is a GPU. What is machine learning and deep learning? This is all tied to artificial intelligence. And why we should be interested in this topic. Again, it's all tied to artificial intelligence. How many types of edge are there? Believe it or not, it's not only defined as one edge computing. And how do you calculate the load of your site in order for you to implement edge computing properly? There are certain things, phrases, words that we should handle with care. Okay, they're called buzzwords, right? In English, disruptive, proactive, pivot, streamline. How do we leverage that? Can we do a synergy? Is there a paradigm shift in our industry? How's the ecosystem, the environment set up? So, and obviously the cloud and Internet of Things, it's all geared into the new Industrial Revolution 4.0, right? So when do we use buzzwords? Well, it depends on who and how are we talking to, maybe potential customers, maybe to our colleagues. Some terms or buzzwords can be disruptive. Others can be proactive and help, to set a level of language between colleagues or a customer, and to deliver the proper message on where and how and when to use edge computing. Okay, just for you guys to keep in mind. What trends do we see, or what are the trends that are pushing edge computing? Well, as you guys all know, dense IT equipment in one rack. We're having, computing at very, very high speeds. And this goes from the enterprise data center all the way to the multi-tenant data center, all the way to, or down to the network closet in a company. So it's computing at the edge, very close to the customer, where we want latency to be close to zero. Now, for all of you, I'll get into that in a second. But latency is the time it takes for data to go from A to B, or from host to host. Network autonomy and resiliency, that's what we're looking for, right? We want to monitor everything remotely, and for it to be resilient, do not have any issues. And if there are issues, then we can respond to them accordingly, depending on what we have there, what type of equipment. And last but not least, how are we going to converge the storage of energy and of all this computing data, and how are we going to back it up in case, to support us in our continuous business plan that we have set up in our companies. So let's look, what's driving the data centers to go from a traditional data center into something called a distributed digital infrastructure. What is that? Well, in the industry, we're looking at three things: cloud and multi-tenant data centers. We're talking about hyperscale data centers that are transmitting high levels of data towards the cloud and interfacing with the cloud. At the lower level, we have distributed IT, we have network classes, we have edge computing, in each rack, very dense computing of data, either from an enterprise data center or a multi-tenant data center where, you're going to have even more data flowing in a multi-tenant. And finally, the core IT, right, which is the data center itself and what it represents. So what are companies looking for? Resiliency again, securing, managing, organizing, let it be at the rack level or at the white space level or at the enterprise level, right? We want these three elements to be integrated so that they will be critical in the management of the business. And this drives the growth of, the power infrastructure of the data center. So we got to pay attention to that. We talked about the three elements, and one of the main elements is the cloud and multi-tenant data centers. Again, interfacing directly with the cloud. But the question arises, well, do I use public cloud? Do I pay and I use a private cloud? Do I have a mix of hybrid cloud? Well, most data centers do have a mix of private and public cloud use, and that's based on what their business plan's continuity is based on, and how they would virtualize or merge, their data in the case of a disaster, right? And I'm taking it to the extreme. But there are different types of cloud. So let's talk about a little bit of this. So you see there, I have tethered cloud or fog computing. For those of you that don't understand the term fog computing, it's considered where you process the data. That's called a fog node. Or if you could put it this way, it's the gateway where all the Internet of Things, and that's one of the terms, IoT, Internet of Things, is within the local area network of the enterprise, okay? So you could put it this way, inside the internet of the enterprise. That's fog computing. And the cloud, obviously, it's a term where you transfer the data to the cloud. It's a third party that offers the service in another site. So tethered cloud is more geared to, okay, well, what information do I share, right? How do I process that data? So it's a nice oxymoron, implementing on-premises clouds through tethered cloud. The fog computing, you have to deploy IT hardware on premise where you need to interface with, different equipment at the rack level. If it's an industrial side, with different types of machines. And that's what we're going to talk about, machine learning and deep learning with the artificial intelligence later on. And how to make it an extension of the services that you're receiving from the cloud, integrated with the, maybe you're doing a fog computing or a tethered cloud in your enterprise. Okay. So we're talking about Outpost, using Azure, a Stack, Google Anthos, just to name a few of what can be an extension of the cloud. So let's get into business. What's edge computing? Well, we can define it as where we process or manage data, but at a local level where we have Internet of Things interacting, interfacing with the embedded computing of the equipment itself, which involves, different equipment, different sensors. But all this information is being processed, again, and that's why I use the word intranet, inside the enterprise. There's no interaction. You don't transfer that information anywhere. You process it locally. And I'll give you an example. Let's say you're doing Netflix. You're watching Netflix. So the stream on the video, they don't go to the cloud, right? Netflix doesn't touch the cloud or the data that they're processing with the cloud that they use in order for them to give you recommendations. That's done locally, and that's part of edge computing. Okay. So what do we have to pay attention in edge computing? Well, there are a couple of things. Latency, which is, again, the time it takes for information or data to travel from A to B. Bandwidth, I'm sure everybody's familiar with bandwidth. But just a quick definition is the amount of data and at which speed does it transfer from sending from A to B in a period of time. So it's, let's say in a minute, how much data can I send or interact with from A to B? That's bandwidth. Security, we talked about it in the previous slides. How do we manage? How do we organize? How do we make sure that our servers are secure, our data is secure, nobody has access to it, and we can interact with security with the cloud if we're doing a Tethered cloud, or even if we're doing locally in edge computing, making sure that all the equipment speak the same language. That's one way of making sure that there's security. And last but not least, analytics. Okay, most of, I would say all of Internet of Things is driven towards, how do we improve, right? The computing, there's algorithms, artificial intelligence, at the machine level, at the deeper level, where algorithms analyze the information and probably can give you recommendations based on alerts, history of equipment, etc. So again, we were talking about why edge appears. I just said it, the Internet of Things. We want to secure the edge to enterprise and back again, that exchange of information, that interface from edge computing towards enterprise data centers and back and forth. From the devices, from the device level, we're talking about gateways and fog computing, through networks towards the cloud. So those are the three elements that we have to integrate in order for edge computing to be successful, implemented in what we call now the Internet of Things. So the first term I mentioned with edge computing is latency. So again, time it takes for computing or request, right, to go from host to host. It's measured in milliseconds, and like I said at the beginning, we're looking for zero latency. The closer you are to zero, the better. Now, there are a couple of commands that are used historically for calculating latency, and it's ping or tracer T. Now, maybe the word or shouldn't be used. I would use the word and. Now, what's the difference between ping and tracer T? Ping is used to tell you if you're reaching a host or a server and it can be reached, and how much long does it take for you to reach that host. That's how you measure that the latency of communication between you and the server, or the cloud and the host, etc. Tracer T, on the other hand, what it does, it calculates how much time. Well, first of all, it shows you how many steps it takes, or how many, and it's called hops. How many hops it takes for the data to go from your site to the cloud. Let's say it takes three steps. It goes from your site to a server. You're in Florida. You send the tracer T. You make a hop from your site to Georgia to wherever the cloud is, let's say, or then from Georgia to California, and you have a cloud in Asia. So it goes to Asia. So there you have 4 hops. Okay. So what tracer T does, it tells you how much time it takes on each hop. Okay. So let's say it goes from Florida to Georgia, it takes a minute, and then from Georgia to California, it takes another minute, etc. I'm exaggerating. It shouldn't be that long, right? Talking about milliseconds. But that's the difference between the two, and it's always used together. But again, people confuse them, and they think they are the same command, but they are 2 different commands. Okay. So what's the idea with, you know, having 0 latency, receiving all this information with the Internet of Things from all the equipment and all of the devices? Well, artificial intelligence. All the big companies have them. You know, Facebook has it. Google has it. Amazon has it. Big companies have, and they work with artificial intelligence, you know, just to make the workflow better, especially at the IT level. And there are 2 types. Well, it's not 2 types in reality. It's 1 type. It's machine learning, but people interchange it with deep learning. But deep learning is a machine learning. Now, for those of you that don't have profound knowledge of the terms, what is machine learning? It's basically computers using algorithms where they learn from the data that they receive from the equipment, and based on that data, they make decisions, or based on those algorithms, decisions, are made. And but the problem with machine learning is that, you know, since it's receiving all this data from the equipment, it does need human interfacing, right? It does need guidance, where, you know, if you see errors, or you know, it's giving a diagnostic to an equipment and the equipment is working correctly, or something's off. So you do need to guide it. You do need engineers guiding artificial intelligence at the machine learning level. Now, if you go into the deep learning part of artificial intelligence, it does use algorithms, but these are structured algorithms. These are layered algorithms that are layered, and they create a big brain, a huge network of neurons, right? And I like to call it ANN, the acronym. It's Artificial Neural Network. And now the difference is that with this brain, with this network of neurons, of all this information and these algorithms layered, with deep learning, artificial intelligence can make decisions without any human interference. So that's the difference between the two. And we will see this with time, you know, that there have been a lot of development in artificial intelligence, and we will see further developments. I'm pretty sure everybody has seen the Honda robot and how advanced it is with interfacing with humans, and other examples of human mimicking gestures that we see coming out in the market. So in order to have artificial intelligence develop properly, that deep learning, that layered algorithms, we needed to have low latency, a strong bandwidth. Why? Because it feeds on information. And based on that information, based on all that data that it receives, with deep learning, artificial intelligence, is able to advance properly for your company and the industry itself. Okay. This is just an overview of what 5G looks like right now. As everybody may know, in the US, it's finally opened in the market this year. 5G is leading the way towards a better data transfer and cell phone networks. 5G, just to give you guys a background for those of you that don't know, 5G works in two different spectrums of radio frequency. At the lower level, 5G is used, for example, not to lose signal when you're inside the building. That's why you see antennas at a lower level, under 50 feet. And at the higher spectrum, 5G is used to, not lose communications at at greater or longer distances. This is an overview of what 5G looks like right now. And there's a lot of potential, again, because it improves the data transfer that we have, and we're looking for zero latency with edge computing. So let's get into what are the edge types. Now remember, there are more than one edge computing, okay? There are actually 6. The cloud, the enterprise data center is not considered an edge computing. But if you go into the regional data centers, co-locations, multi-tenant data centers, those are considered regional data centers because they are most likely closer to the user itself. You have micro data centers for those of you that don't know what micro data centers are, it's basically a server, storage device, network switch, and a backup power system all stored in one rack and can be deployed. It's plug and play type, easy to monitor, etc. That's being sold in the market. Usually, it is purchased and I'll give you an example in the financial sector, in banks employed in their branches. That's what micro data centers is geared towards, not necessarily only the financial market. And if you want to call it enterprise edge, it's a combination of regional and local edge. Then we have something called the shallow edge, which is going into the computing edge. And what do you mean computing edge? Yeah, it's not in the data center, but it can be in the gray space where we have human-computer interfacing, right? That's the acronym that you see there, HCI. Which is, part of user interfacing at the computer level, and that's why it says compute edge. So that's the shallow edge. If you want to group those two terms, local data center and computer edge. We have the gateway edge, this is at the network level, okay, where you have the network switches, you have your access points, this is part of the network closet. Let's say if you're working in your office and you have your network closet, that would be part of the gateway edge. And the device edge, finally, which is where we go at the embedded level of the components inside the equipment, where, again, either the equipment itself or sensors connected to the equipment is sending data to either you're doing fog computing, we talked about that before, data processing in the fog node or in the gateway itself within the local area network, or you're doing some type of tethered cloud where you're using edge computing and communicating with the cloud, delivering this information. Either you use a third party or you're doing a self cloud on a private cloud on another site of your company. And finally, this is to answer the first question of the polling. The IIoT is Industrial Internet of Things, and that's one of the terms of edge computing. So you have there 6 edge computings, and regional data center edge, local data center edge, compute edge, industrial Internet of Things edge, gateway edge, and device edge, which is part of the deep edge computing. If you want to group those 4 edge computing types into one umbrella, would be deep edge. Now you see on the right, let me emphasize on this, on industrial Internet of Things, it says IT-OT convergence. Most of you know this, but just to give you a refresh, IT is the acronym for information technology, covers all the technologies that process information. And OT is operational technologies. And this is where we're talking about at the hardware and software level, of the embedded components, where we're going to monitor and control the equipment. If we want the equipment to set an alarm, send us an alarm if something activates, if the door opens, or one of the equipment fails inside the rack, etc. So let's do a deep dive on each one of these edge types. The first one is regional data center edge. Where are we going to with the regional data center edge? Remember, this is for co-location, multi-data center providers. We're looking again to manage, protect, and distribute within these multi-tenant data centers, enterprise data centers, where we have highly condensed power consumption in the racks. We are talking about multiple servers in one rack or in an aisle of racks. So either you're doing power distribution at the rack level or at the row of rack level, or maybe at the white space level. So you need to know you have a high density of outlets needed, and limited time to remotely management. So those are the issues that we can address using edge computing. What are we looking for? What are the solutions we're looking for? We're looking to distribute properly, again, all this power that is needed at the row rack level. We need to protect it. We need a backup system, preferably if it's scalable, up to 60 kilowatts, depending on the size of the amount of servers that you have in the rack, servers and storage. The best way to do it is, edge computing is, we're talking about having everything pre-assembled, do a plug and play type scenario, easy to install, easy to deploy, easy to remotely manage. And we're looking to analyze and have predictions, right? We want to predict what's going to happen so I can have a service schedule for my data center, my multi-tenant data center. So that's the solutions we're looking for with edge computing at the regional data center type. If we look at the local data center edge, again, this is closer to the user, still focusing on latency issues. Okay, everybody wants streaming fast, video streaming, music streaming, accessing data quickly. And at the retail level, well, better experience, especially now with COVID-19, we've seen that we're progressing towards having a user-friendly interface with our customers, and it's all supported by edge computing. Again, we have high power densities at this edge type. We want to access maybe the information at the local level. We want to connect directly to the equipment on the rack. And we have limited staff. So again, we want to manage remotely all the equipment on the racks. So what solutions are we looking for? Organize, protect, and manage. How do we organize this? Rack PDUs installed on the racks themselves. Security at the fog node or at the IP address level. We protect it with backup systems. We don't want our data flow to stop. That should be part of everybody's business continuity plan. Have a good backup power system and have it virtualized. And we'll talk about that in a couple of slides more. We'll talk about virtualization. And how we need a good software. We need the software in order to manage it properly. We need all the software that we're using from all this different equipment inside our network closet, micro data center to understand each other, right? So they have to speak the proper language, or at least have a good translator. And what I'm talking about is working with the same maybe framework in the network itself. The next type is the human-computer interface level, which is the computing edge, and this is now to the bone structure of the whole interfacing between the cloud and edge computing. At the local level, we're looking to distribute, integrate all these systems, manage them. But what are the issues that we may have? Well, you know, I'm in an office and my network closet doesn't have that much space. I can't expand here locally or in one of my branches or one of my sites has limited access, limited space. Maybe I'm having issues electrically with that site. So how do I manage that? How do I solve that problem? First, we got to organize it properly. If we have limited space, you know, in the market, you're going to see various enclosure types of various setups, either floor standing, wall mounted, that you can have, where you can have power systems and backup systems installed. At the rack level, you know, there are different accessories that you could put on where you can have airflow management, you know, not have all these cables all over the place where maybe if there is an equipment that a technician has to go in and repair and, you know, with this, you know, trying to repair one of these equipments or take off a screw, he moves his elbow, one of the cables goes loose and 100 customers go down, to give you a very extreme scenario. We don't want that, right? So that's one way to solve that problem at the computing edge level. It's organizing with this airflow management type of accessories. We protect it again with a good backup system. We also want it improve maybe the backup time, and that's tied to virtualization, which we were going to talk about in a few slides. And in order to protect it, the UL recently has launched, or, you know, the word, yeah, you could say that, given a standard towards cybersecurity, and it's geared towards, you know, the type of protocol and the network connectivity cards that should be used when you're trying to secure a backup system and all the equipment that the backup system is supporting. And this goes tied to what type of software, what security do I have in the software? Do I have a host login? Do I have a host customer login where the host must give access to the customer if they want to access their data in the server, especially in the multi-tenant data center scenario. Okay, and again, the acronym IIoT is for Industrial Internet of Things, edge computing. Here we're talking about communicating with the sensors connected to the equipment that we have, maybe in our plant, and So we need to compute that information locally. That's part of edge computing, where we don't want to interface with the cloud, because that's something that should be done at the deeper learning level of the machines. And obviously, all this data coming in, you need a lot of processing, very dense computing, a lot of information being exchanged. And usually we see this in, as the name says it, industrial type, where we're going to have environments, we're going to have dust, maybe, you know, at an oil site, or if it's an offshore site, where we could have issues with corrosion for the salt levels if you're at the sea level. And we're looking to converge, you know, IT, OT, we talked about this previously, operational technology and information technology. Again, the solution is organize, protect, and manage. These are three concepts that you've seen in the past slides, and you're going to see in the next two slides, that makes emphasis on those are the concepts that we have to focus on when we're going to solve power solutions or power management solutions at edge computing level. If we want to organize it, we need a good backup system. We need it to be rough, right? Because it's going into harsh environments. It has to support these harsh environments, which usually are very high temperature scenarios. And we're looking at capacities that do not go beyond 20 kVA, N+1 if you're looking for redundancy, which is always a good thing. Protected cybersecurity equipment that's UL, either UL or IEC certified, and manage, have remote access to the sensors themselves connected to the equipment, making sure that we can give a predictive analysis of what's going on in the environment, either in our plant, processing plant, offshore site, oil and gas site, etc. Another type would be the gateway edge. Where do we compute at the gateway level, and what is it that, or what are the issues you can see? Well, again, we're talking about network closets. There's limited space. Maybe we have issues with security. Again, we're talking about network closet, a small rack maybe inside the building. Maybe there's no IT staff because it's a remote site. And having an IT person there is probably too expensive, and maybe having an IT a service plan where you have the person going or monitoring the site 24/7 could be out of budget for us. So in order for us to manage all these power situations that can be involved with these limitations, again, the three concepts: organize, protect, manage. In the market, you will see different type of enclosures, again, either floor mount or wall mounted. If you have limited space, accessories that go on the rack where the airflow can be smooth, where you reduce the amount of heat being generated because of all these cables being entangled with each other in back of the servers, and maybe you don't have an enclosed rack. So the accessories will help to better the temperature. Protect, again, a good backup system. The technology with lithium-ion batteries in the past 3 to 5 years has improved dramatically, and even now we're seeing new improvements on the type of metals being mixed with lithium in order for it to withstand higher temperatures, last longer, have less cycles of charge and recharge. So in the market for backup system, we're seeing great advancement, and it's always recommended, especially at the gateway edge computing type level, because, you know, It's maybe, again, a network closet at a site that's remote. It's expensive to go there. So we want a backup system that'll guarantee that it'll last 10 to 20 years. And I don't have to give service to the batteries themselves. And we can manage this with the software remotely. Again, a software, making sure that the software speaks the same language as the equipment that we have on that remote site and our headquarters. And that ends the 6 types of edge computing. So now you guys know there are 6 types of edge computing. And I mentioned, how do we manage this? How remotely? What is it that we're looking for? How do we manage the power? Well, there's something called power capping. Most of you have heard of this term in the market, where we're trying to manage the power by simply either putting in standby or shutting off non-critical loads. And these are maybe equipment inside the rack that are consuming too much power that we don't really need in case of a disaster. Maybe servers or clients that are not active, and we have a storage device that it isn't accessed, that data isn't accessed frequently. So that could be part of the power capping situation. So the 5th element in edge computing would be virtualization. What does that mean? Virtualization is used when you want to power cap your rack or the racks in a row of racks or in your data center, and when you want to minimize the amount of critical loads that the backup power systems are supporting. And that will, at the end, what we're looking for is to extend the backup time we have available with the batteries on site. So I'll give you an example. We have a 15 kVA load running at 5 minutes, and there's an issue. We can start virtualizing power capping on site and migrating data on these storage devices, migrating that data to a remote site or maybe a private cloud, or maybe we're using a hybrid with public-private clouds. We're migrating this data towards the cloud, and at the same time, it's power capping or turning off these network devices in a rack. And that'll extend, instead of it being 15 kVA in 5 minutes, you can support 15 kVA to extend it to 10 minutes, 8 minutes. So we're getting better backup times for critical loads. Now, what do we define as critical loads? Well, critical loads are servers that we can't shut off because obviously our business depends on it. It's interfacing. We're a streaming company, so we need to be constantly streaming all this information. So we can't afford to stop data streaming over a bank, and we can't stop the flow of transactions for certain branches or certain customers. Okay, so that's the 5th element inside the edge computing, virtualization. Okay, I'm on time. Okay, I'm doing good in time. So let's talk about the energy consumed on our sites. UPS is the acronym for uninterruptible power structure or power device at the energy level of your data center. Now look at that picture. Does it look complicated? You see those cables? If you see it in that picture right now, that has a good airflow, even though we see all that dense wiring, it is organized. So if you look at the image on the right, this is typically what we see in the rack, right? We have a switch, we have a server, we have storage equipment, and maybe we have a server with a different voltage. If we have a server or an equipment that is from a different voltage, we do need maybe a transformer inside the rack. If the UPS is not a split phase UPS, which you will see in the market, they are But traditionally, it's a single voltage UPS, and a external device is used as a transformer or a step-down transformer to get, in this case, or in this scenario, 120 volts. This is typically what you see in a server, in a rack. And you see this ePDU, which is a rack PDU, which would provide all the outlet power consumed by the equipment on the rack, and backed up by the UPS itself, the uninterruptible power system or power device. So how do we calculate this at my site? How, what do I have to look for? Well, usually some equipment will tell you how much it consumes, or the rating of the maximum capacity that the device will consume. You see it here on your left, it says 870 watts. That's usually one way. You look at the label, you look at the wattage, how much is it consume, and you just sum up the wattage of the equipment inside the rack. If you don't see the wattage itself, the labels in the back of the equipment or on the side of the equipment do show the input-output voltages and the amperage that it will consume at that voltage. With this information and this formula you see here with the label sum method, you calculate power, voltage times current, and then just as a safe measure, and this is because sometimes you can overload equipment. There is a tolerance. You divide it by 0.8. You give it that 20% excess of load, just to make sure you're safe. So you do that for each equipment on the rack. You then do a sum of all this power, and it'll give you the total power that you have on the rack. Typically, again, that we see in a micro data center scenario, at the local data center or the local edge computing level, we do see 15 to 20 kilowatt. Now with all this dense computing, we are seeing up to 30 to 35 kilowatt consumption on the rack level. And this is for big enterprise data centers. So that's for you guys to know, at your site, how to easily calculate how much energy each rack is consumed. And again, it applies also if you calculate on one rack, you do it individually for each rack, and you calculate the power consumption on the row itself. If you're doing power distribution at the row level of racks, instead of doing it individually for each rack. So that's something to keep in mind. So that's it for me. Any questions? Please feel free to put them through chat.
And we have a couple of questions, Julián.
Great. Okay.
Yeah, you talked a lot about infrastructure. I noticed that you showed us that 5G map. And the question that we received, it's about Latin America. Are Latin American countries ready for this new edge?
Well, I would say that it's being developed. In order for this new edge with 5G to be properly executed, we do need more development at the infrastructure level. But we're working on that at the regional level. We have big companies, big cell service providers, Claro, just to give you a name, Claro, WOM from the south, coming from Chile. They're going into markets, and they're building on the current infrastructure to work with, first of all, 5G at the lower spectrum, because that's the easiest way to work on 5G. You work on the lower spectrum, the lower frequencies of the spectrum, in order to have proper 5G, going in and out of buildings, especially in dense areas, dense urban areas or in cities. But it is being developed. We are working with, big companies, and we do see that the market is advancing. Not as advanced as we see in maybe, Asia, Europe, here in the U.S. But I would say that the South American countries are on the right path. And in the South, they've been doing a lot of good stuff too. I'm talking about the South Cone of South America.
Excellent. And the second question, I think that is so tied to the first one. This person say, I suppose that these technologies are still very expensive. And when will it be convenient to start implementing them?
Well, you're absolutely right. I mean, especially with 5G, that's where you get into the more expensive side of things. And what we're seeing is that the market is pushing to everybody in the market to adapt. And maybe with this adaptation, with this surge of demand, we will see the prices, level out. The economies in South America are huge. They're growing at a very, very fast pace. And the applications are a necessity now. Before they were a luxury, but now with the advancement, with everybody on Facebook, everybody on Instagram, everybody streaming video, having all these services like Netflix, etc. They want their information. They want all this. They want all their services now, and they don't want to wait for it. Right? That's why we talk about latency. The closer we are to zero, the better. And the only way, unfortunately, to ensure it is there has to be an initial investment. Yes, it's costly, but the benefits can be greater in the long run. And there are ways to do that. Not necessarily focusing on 5G, just with a good backup system and having that virtualization narrowed down for your business continuity plan. That's a good beginning for you and to lower your cost in implementing edge computing.
And there's another one, and we don't have that much time, but I think it would be good to hear your feedback on this. Is there any danger of fire with large quantities of lithium-ion batteries in data centers and in closed spaces like you described?
Well, no, well, that's a difference between lithium batteries and what's traditionally used in backup system, which is the VRLAs, right? The lead acid type of batteries. With the lead acid type of batteries, usually in a data center, they're installed in the gray space of the data center in a separate room where you have some type of good ventilation, adequate temperature. So you have an adequate environment to have these batteries, and also you have to have a good service plan because you do need to service the lead acid batteries more frequently, and you have to monitor them. They do need sensors to monitor, what's the amperage consumption of these batteries, at what temperature are they operating, is inside the string of batteries is maybe one cell damage. So all these things you do need to constantly monitor versus what you have with lithium batteries is, first of all, the technology allows you to work at higher temperatures. You should not have ventilation. You can't, that may be the hazard if you don't change the environment. So towards not having ventilation at all, because ventilation will make them hotter. Lithium technology is used in hot environments. The other advantage is that it already comes with a battery management system integrated in the rack of lithium batteries. So that's another plus for it to constantly monitor. So you don't have to invest in all these different type of services or accessories to monitor the batteries. It's already integrated into the lithium battery cabinet.